Welcome back to our lesson. We are still revising acids and bases. Now let's look at another type of structured questions which involve a lot of stoichiometry, which cuts across in any of the problems that have got chemical reactions. Right. Now, in this case, we've got anhydrous oxalic acid. Now, anhydrous suggests that there is no water of crystallization in these granules of oxalic acid, whose formula is C2H2O4. It's a good primary standard. And if we talk about a standard, what are we talking about? We're thinking a standard solution whose concentration is actually known, okay? And it can be used to standardize the concentration of barium hydroxide. So at the end of the day, barium hydroxide is a base, while oxalic acid, as the name suggests, is an acid. We're given 4.5 grams of the solute, right, are used to prepare a 125 cubic centimeter solution, right? So the solute are granules that will dissolve completely in water in that given volume. So the question says, calculate the concentration of the acid. Now, which acid are we talking about here? We're talking about oxalic acid. Now, remember, if we are to determine the concentration, we know that concentration of a substance is equal to number of moles over volume, right? But we have to first of all determine the moles, and we know that the moles of a substance is equal to mass over molar mass. So as a result, we can safely say concentration is equal to, this is from the data sheet, is equal to mass over molar mass multiplied by volume, right? So what is the mass of the solute that dissolves completely as we form this standard solution is 4.5 grams, right? Divided by, what's the molar mass of oxalic acid? 90 grams per mole, right? And then the volume of the solvent that is used to form this solution is 125 cubic centimeters. So it's a homogeneous solution that will be formed. So 125, we convert this to cubic decimeters, we divide it by 1,000, which is 0.125 cubic decimeters. Right, so this is 0.125, okay. So we are able to determine the concentration. So from there, we can go to our calculator and say 4.5, okay, divided by 90 multiplied by 0.125, right, okay. So this gives us, we can change that 0.4 moles per cubic decimeter, right? So the concentration of this oxalic acid is 0.4 moles per cubic decimeter, right? So that's how we determine the concentration, right? So be careful when you use the calculator. So in some cases, it will give you the answer as, as a fraction. You are able to convert that to a decimal fraction in terms of, 2 decimal places. Very, very important, right? Okay, and then the follow-up question, it says 25 mils, that's the volume of acid. So we know that the volume of acid that was used, okay, is equals to 25 cubic milliliters, 25 milliliters. I prefer to work with the SI unit. Is if you divide that by 1,000, because 1 cubic decimeter, right, is equals to 1,000 cubic milliliters or cubic centimeters, right? So that volume is 25 mils, all right, which is equals to 0.025 cubic decimeters. That's the volume. Okay, it's diluted with distilled water to make that concentration, right? So what do we know? We know that the concentration of this acid, we have managed to calculate the concentration and managed to get 0.4 moles per cubic decimeter. Now, that concentration is diluted with an unknown volume of water to give a new concentration of 0.015. So that's why the concentration has decreased, because we have diluted. But what remains the same is actually the number of moles. Now the question demands us to calculate how much water was added to the oxalic acid. So this question is basically about dilution, right? So what is it that we know in terms of dilution? We know that we can use the formula concentration 1, which is the original concentration, volume 1 of the actual acid before we added the water. So when you dilute, we will get concentration 2 and volume 2, right? But what remains the same is the number of moles, right? So concentration 1 is 0.4, right? Multiplied by the initial volume, which was diluted, which is 0.025. We've already converted 25 mils to cubic decimeters. Now the new lower concentration after adding more distilled water becomes 0.015. Okay, now we want to understand what's the new volume. This is going to give us an indication of how much water was added, right? So we can be able to determine the new volume after adding water, right? So we can go to our calculator and say, right, okay, what do we have here? We have 0.04, right, 0.4, right, multiplied by 0.025, right? We divide this by 0.015, which is the new concentration. We're just making V2 the subject, okay? So we'll divide by 0.015, right? What do we get? We get, okay, what do we get from there? Okay, this gives us 3/2. So this is the new volume as a decimal fraction. The new volume is 0.67, right? 2 decimal places. So this is 0.67 cubic decimeters. Now, if the initial volume was 25 mils, and then the new volume is 67 mils, because this is like 67 milliliters. So how much water was added? So we are saying volume of water added, okay, is actually equal to, V2 minus V1 in a dilution, okay? Right, so the second volume, the new volume is 0.67 less the initial volume, okay, of the solution, which is 0.67 cubic decimeters, and then 0.025, okay? Right, okay? So everything is in cubic decimeters. So if we go to our calculator, what do we get? We have 0.67, okay, minus 0.025. Okay, what does that give us? This gives us 0.645, right? So 0.645 cubic decimeters of water was added. So you can change that to cubic centimeters, but you don't have to. So this is the actual volume of distilled water that was added in the dilution process, right? Okay, and then we've got another one which says 40 cubic centimeters of nitric acid of an unknown concentration, all right, is used to neutralize that volume and concentration of barium hydroxide. So 25 cubic centimeters and 0.05 moles per cubic decimeters are for the base barium hydroxide. So this is the balanced equation of the reaction between nitric acid and barium hydroxide, right? So what do we have? What name is given to the technique used to determine an unknown concentration of a solution? Right, the calculations that we've been doing have to do with volumetric analysis, but the technique that we carry out in the lab is actually a titration, right? So this is a question based on remembering. So this is about a titration, which is a technique, right? Okay, and then the question says, calculate the number of moles of base that reacted. Okay, how much volume of the base reacted? 25 cubic centimeters. What is the concentration of the base? 0.05 moles per cubic decimeter. So we want the number of moles of base, so which is the number of moles of barium hydroxide, right? Okay, is equals to concentration multiplied by volume, right? Do we have the concentration? Yes, the concentration is 0.05, right? So the formula is from the data sheet. We copy it, and then we want to find the number of moles. So 0.05, which is the concentration, multiplied by the volume, which is 0.025, okay? So we are able to determine that by saying, okay, 0.05 multiplied by 0.025. This gives us the number of moles, okay? So the number of moles is equals to 1.25 times 10 exponent minus 3. 1.25 times 10 exponent minus 3 moles, right? So that's the number of moles. So this is a routine calculation where you've got the formula, substitution, and the correct answer, including the correct SI unit, right? And then it says here, calculate the concentration of the acid. Now, the stoichiometric ratio in which they react is very, very important. It says 2 moles reacts with 1 mole, right? But how many moles of the base reacted? 1.25, okay, times 10 exponent minus 3 mole, right? While we are saying double the number because 2 reacts with 1. So 2 moles of that will be the number of moles of the acid that react will be actually double those of barium hydroxide, which is 1.25 times 10 exponent minus 3. Okay, so this is the number of moles. Okay, now we are also told that the volume is that. Now, if we want to find concentration, we know that concentration is number of moles per unit volume of solution, right? So the concentration is 2 times 1.25 times 10 exponent minus 3, okay, divided by the volume, which is 40 cubic centimeters. 40 is 0.04 cubic decimeters. So C becomes, right? So what do we have here? We have got the calculation, 2 multiplied by 1.25 times 10 exponent minus 3, okay, which is double the number of moles of barium hydroxide, okay, minus 3, okay. Okay, we close that bracket, divided by 0.04, okay. Right, so this is the actual concentration of the acid, nitric acid, 0.0625, okay, 0.0625 moles per cubic decimeter. Right. All right, so these are some of the few examples that we have used. So it will be very important for you to try and revise so that you become more comfortable. That's the time we had for today. Goodbye.